is the Vice President for Asia-Pacific region of Unilever's Clear for Men shampoo. He supervises 3 factories, Hanoi, Manila, and Beijing, that supply 3 warehouses, Seoul, Sydney, and Tokyo, in the region. Hanoi can produce 300 cases, Manila can produce 500 cases, and Beijing can produce up to 100 cases per week. Meanwhile, Seoul's demand is 600 cases, Sydney's demand is 400 cases, and Tokyo's demand is 200 cases per week. The shipping cost per case from Hanoi to Seoul is $8, to Sydney is $2, and to Tokyo is $10. The shipping cost per case from Manila to Seoul is $4, to Sydney is $7, and to Tokyo is $6. The shipping cost per case from Beijing to Seoul is $5, to Sydney is $9, and to Tokyo is $3. How many cases will Alan ship from each of the 3 factories to each of the 3 warehouses in the region per week, while minimizing shipping costs?
Alright, so good day everyone. Welcome to our next discussion and the continuation actually of our transportation models. Okay, so before that, let's have some recap first. Actually, we have 3 different methods of solving the transportation models. For the first one, it is the northwest corner rule, or some books call this as the northwest corner method. It's just the same. For the second method, it is the least cost method. Some OR analysts call this minimum cost method. It is just the same. And the third one is the Vogel's approximation method, or what we call the VAM. And this is actually this presentation is all about. We will be having some talks regarding the VAM way of computation here, or solving the transportation models, and it is actually unbalanced transportation. No? So as you can recall, we have 2 types of transportation problem, which is the balanced one and the unbalanced. So again, for this presentation, this is an unbalanced transportation problem, and we will going to solve it using the Vogel's approximation method. Alright, so let's start. Same with our previous example on our unbalanced na computation regarding northwest corner rule and the least cost method. Let's use this one, the clear shampoo na problem. So here we have Alan, which is the Vice President for Asia Pacific region of Unilever's Clear for Men shampoo. He supervises 3 factories which are located in Hanoi, Manila, and Beijing that supply 3 warehouses, which are the Seoul, Sydney, and Tokyo in the region. Hanoi can produce 300 cases, Manila can produce 500 cases, and Beijing can produce up to 100 cases per week. Meanwhile, Seoul's demand is 600 cases, Sydney's demand is 400 cases, and Tokyo's demand is 200 cases per week. The shipping cost per case from Hanoi to Seoul is $8, to Sydney is $2, and to Tokyo is $10. The shipping cost per case from Manila to Seoul is $4, to Sydney is $7, and to Tokyo is $6. The shipping cost per case from Beijing to Seoul is $5, to Sydney is $9, and to Tokyo is $3. The question is, how many cases will Alan ship from each of the 3 factories to each of the 3 warehouses in the given region per week while minimizing the shipping cost? So I hope you get it, and I hope you take some notes regarding our problem. Okay, so as you can see here, this is actually the previous writings regarding our computation for this unbalanced problem, and we use this on the northwest corner rule and this least cost method solution. And here we are on these writings on the solution. We actually notice that the table or the given problem is unbalanced through the 900 and 1200 total capacity and total demand. And meaning to say, if our demand is higher than our supply, of course, it is actually shortage. So what we should do before we start with the VAM method is that we should have our dummy factory here, and that is 300 capacity for us to be able to complete the 1200 demand. So 300 plus 900 is actually 1200, and that step actually makes our table from an unbalanced tableau to balanced tableau. And we should clean this first before we proceed with the VAM method. So, written here, convert unbalanced table to balanced table first. And this is actually converted already. But before we start our Vogel's approximation method, we should copy this one and gawin natin na mas malinis pa. Sige, let's start. So, I'll use white ink. Okay. So, let's have here factory. I will try to have our table on the upper left side because for this Vogel's approximation method, we will be consuming an extension part, which we will extend our table to the right and bottom part. So we have factories from Hanoi, Manila, Beijing, and of course our additional factory, which is the dummy factory. Let's have here dummy. And demand, which is in the unit of cases. Okay. Alright, so for our labels on our columns, those are the warehouses. Let's have here the Seoul, the Sydney, and the Tokyo. Okay. General label, let's have warehouses. Okay, then let's separate these columns. Okay. And on this part, let's have capacity. Our capacity and demand should be in same unit, guys. Huwag makakalimutan. Kung ito ay cases, the demand should also be in cases. If ever na may mga problem na binigay na magkaiba ng unit, you should convert the one, either of the two. No? So, okay na. Hanoi, lagyan din ng separation. Ito. And for the cost, let's copy the given cost, 845. Let's have here 8. Here, this is 4. 5. For the dummy, since this is dummy, actually there's no actual factory. Therefore, our cost will be 0. Same for all warehouses. Warehouse column. Okay. So for Sydney, we have 2, 7, and 9. 2, 7, and 9. For the Tokyo, we have 10, 6, and 3. 10, 6, and 3. Okay. For the demand, we have 600, 400, and 200. Oops. Okay. 600, 400, and 200. And for the supply or the capacity, 3, 5, 1, 3. Let's have 3, 5, 1, and 3. Okay. And let's have some checking. 3 plus 500, that is 800. Plus 1, that is 900. Plus 3, that is 1,200. 6 plus 4, 9. Plus 2, 12. 1,200. 200. Meaning to say, our table now is a balanced one. So we can proceed with the normal solution of our VAM or the Vogel's approximation method. So for the first solution, as you can still remember, sa Vogel natin last time, gawa mata, extend muna natin ito before ko sabihin yung mga steps. Extend natin. I hope you still remember how to solve VAM. We will be using these extensions later. Same with this one. Let's extend this. Go down. I hope you have your paper with you. You solve kasabay ko. Okay. Okay. So for first part, actually we should solve or we should compute for the first penalty points. First penalty. So here, first penalty ng ating row and ng ating column. First penalty for column. Oops. We'll delete this one. Wait lang ha. Ang hirap magsulat sa PowerPoint. Parang elementary, nag-aaral magsulat. Okay. So, for first penalty, again, ang tool natin para mahanap ang penalty, we should find the two smallest cost. In our case, for this row, the two smallest cost is 8 and 2. Therefore, we should have 8 minus 2 on this cell, and that is actually equals to 6. Same with Manila. The two lowest cost here for 7 and 6 is of course 6 and 4. So 6 minus 4, this is 2. For Beijing, we have 5, 9, and 3. So basically, our two smallest number or two smallest shipping cost is 5 and 3. So 5 minus 3, this is 2. For the dummy, those are all 0. So, yan, 0 lahat. For first penalty, the two lowest cost is 4 and 0 under the column of Seoul. So 4 minus 0 equals 0. For the Sydney, 2 and 0. 2 minus 0 equals 0. For the Tokyo, we have 3 and 0. So 3 minus 0 equals 3. Sorry, this is 2 and 4. Okay. So we have 4. We have 2. We have 3. We have 6. We have 2. We have 2. We have 0. So, ang pipiliin natin dyan sa mga penalty points na yan is of course ang pinakamalaki, the largest value, which is 6. Ayan ang ating pipiliin. And dito sa 6 na yan, you look on this row, 8, 2, and 10. Piliin naman natin ngayon yung pinakamaliit. And doon tayo maglalagay ng ating unang allocation. So, meaning, 8, 2, and 10, pinakamaliit is 2. Ngayon, ano yung dinedemand ni Sydney? They are demanding a total of 400 Ks. Ano naman yung kayang ibigay ni Hanoi Factory? They only have 300 on their capacity. Therefore, lagay na natin dito 300. Lahat ng kayang ibigay ni Hanoi kay Sydney, buo na yan. And meaning to say, this will be 0. And kung 0 na yan, wala nang maibibigay. Si Hanoi Factory kay Tokyo, 0 na to. And of course, kay Seoul. Ayan. And ito, nagbigay siya ng 300, So, 400 minus 300, this will be 100. And that's the first part. And ulitin lang natin lahat ng ginawa, Just repeat all steps. For now, let's have the second penalty. Until all the vacant cells have their values. Ganyan lang naman itong ubang. Madali lang ito, pero mahirap kung aaralin mag-isa at kung aaralin gamit ang book at kung ano-ano pang mga paper resources sa online. Ang tinuturo ko sa inyo, lagi yung pinakamabilis na way. Yung mga shortcut technique ko na yan. So, ayan. For second penalty, since wala na tayo ditong vacant cells, lahat may laman na. Even 0 yan, no? Considered as, ano na yan, may laman na siya. Dahil wala tayong ibibigay, wala nang capacity. Wala na dito, natin kukumpitin dyan for the second penalty. Start tayo for this row ng Manila. 4, 7, and 6, the two smallest values are 4 and 6. So, let's have here 6 minus 4, that is 2. Same with Beijing, 5 and 3. So, as you can see, it is just the same with our first penalty column, no? So, 5 minus 3 is 2. For the dummy, 0 minus 0 is basically 0. Now, let's have here 4, 5, and 0. The two smallest values are still 4 and 0. So, 4 minus 0 is 4. For the Sydney column, 7, 9, 0, we have 7 and 0. So, 7 minus 0 is 7. Okay, for the Tokyo, we have 6, 3, and 0. So, 2 smallest is 3 and 0. So, for all our second penalty for the column, as you can see, pareho lang lahat, no? Sa una. Maliban dito pala sa Sydney. So, 3 minus 0 is 3. Okay. Now, the next one is to get the highest value of all our penalties. 2, 2, 0, 3, 7, and 4. The highest between all our second penalty is actually 7. Meaning to say, on this column of 7, dito tayo pipili ng next nating lalagyan, ng next nating allocation. Now, as we can see, the smallest cost dito sa grupo na to, 2790, is actually 0. And ano yung dinedemand ni Warehouse Sydney? 100. Pero ang dummy account natin or ang dummy factory natin, kaya niyang magbigay ng 300. 100 na nga lang kailangan. So, meaning to say, lagyan na natin to ng 100 para wala nang kailangan si Sydney na warehouse. This will be 0. And kung 0 na yan, wala na rin siyang kailangan sa Manila na factory. Wala na rin siyang kailangan sa Beijing na factory. And this will be 200. 300 minus 100 is 200. That's it, no? For the second penalty. Let's have now our third penalty. Paulit-ulit lang yan hanggat hindi na natatapos. No, hanggat di napupuno lahat ng nasa table natin. So, we have third penalty here and dito. Okay. So, okay na to. Wala na yan. And ang natira dito is 6 and 4. So, 6 minus 4, same pa rin. This is 2. Dito is 5 and 3. 5 minus 3. This is 2. And for the dummy, parehong 0. 0 minus 0, this is 0. Pababa naman tayo sa mga warehouses naman, columns naman. So, 4 minus 0, parehong maliit yun. Yung pinakamaliliit. This is 4. Dito, wala na. No, kasi meron na lahat eh. For the Tokyo, still 3 and 0. So, 3 minus 0 equals 3. Ano yung pinakamalaki? We have 2, we have 2, we have 0, 3, and 4. Of course, this time, ang pinakamalaki natin is yung 4. Meaning to say, dito tayo titingin, no? Ano yung meron pang, or ano yung cell na may pinakamaliit na cost? Basically, that is 0. Now, kung 0 yan, ano yung kailangan niya? Sabi ni Zol, ang kailangan niya is 600. Pero sabi ni Dummy Factory, kaya niya lang magbigay ng 200. Therefore, ibigay mo na yung lahat para 0 na to. And kapag 0 na yan, wala nang ibibigay si Dummy Factory kay Tokyo. 0 na rin ito. Si Seoul naman, dahil nabigyan na siya ng 200, ang kailangan niya is 600. No? So, 600 minus 200, 400 na lang ang kailangan. And that ends our third penalty. So, our third part ng ating solution. Let's have now here the fourth penalty. Okay. Okay. Now, for this fourth penalty, ito is wala na, no? Tapos na yan. 6 and 4 pa rin ang titira dito. 6 minus 4. This is 2. And 3 minus 5 or 5 minus 3 rather. This is 2. Parehong-pareho. Dito sa dami, wala na. Tapos na siya. So, dito sa ating fourth penalty, baka may pang fifth pa no? Hatiin na natin. Baka makulangin tayo sa space. For the fourth penalty, we have 4 and 5 or 5 minus 4. This is 1. And dito sa Sydney column, wala na. Tapos na siya. Dito we have 6 and 3. Ayun na lang dalawa ang naiwan. This is 3. Okay, let's check. We have 2, 2, 3, and 1. Which is higher? So, of course, ito, 3. Therefore, dito naman tayo titingin. Ano yung pinakamaliit sa lahat ng mga shipping cost na wala pang laman? So, ang naiwan na lang is 6 and 3. So, ano mas maliit dyan? That is 3. Now, itong cell na to. Yung cell ng Beijing to Tokyo. And sabi ni Beijing, kaya niya daw magbigay ng 100 capacity. Yun nga lang, ang kailangan ni Tokyo warehouse is 200. Therefore, ibigay mo na yan lahat para at least kahit paano mabawasan yung need niya. No? So, ito ay magiging 0 na. And kapag 0 na yan, wala lang capacity si Beijing na magbigay kay Seoul. Therefore, 0 na rin ito. And itong kailangan ni Tokyo na 200, nabawasan na ng 100, 100 na lang ang natira. Okay. So, let's proceed with the fifth penalty. Okay. So, for fifth penalty, ito is penalty. Sorry for my handwriting. So, ito wala na. 6 minus 4, that is 2. And, itong Beijing, okay, wala na rin. For dummy, wala na. For Seoul, ito, ang natira na lang natin dito, take note of this guys, ang natira na lang is 4. Yung 4 na lang, wala nang iba minus. Ibig sabihin, yung fifth penalty mo dito, na ang hirap na magsulat dahil lumalabas yung mga icon na yan, is wala na. No, wala na yan. Ito, lalo na, wala na kasi kanina pa yun. Tapos, ang hirap magsulat na lumalabas. Anyway, sige. Dito din, same concern with the Seoul column. 6 na lang eh. Kahit sa mo, ima-minus, wala na. No, so, wala na yan. Meaning to say, ang natirang penalty points na lang natin is itong 2. Therefore, dahil nandito yung placement niya, ang tingin natin, horizontal na. Sa Manila na row. No? So, let's compare. Which is lower? 6 or 4? Basically, 4 tayo. No? Sabi ni Seoul Warehouse, kailangan niya pa ng 400. Sabi ni Manila, okay lang, no? Kaya ko magbigay ng 500. O, di ba? So, tapusin na natin yan. Ibigay ang kailangan ni warehouse na 400. Para ito ay 0 na. Wala na siyang kailangan. At may matitira na number of cases sa Manila factory natin na 100. And kung titignan nyo, since this table is a balanced na transportation table, yung 100 na natirang capacity ni Manila is eksaktong-eksakto sa natira ni Tokyo na demand, which is 100. So, meaning to say, pwede na po natin yan ilagay dyan, 100, para sarado na yung buong table, 0 na ito, 0 na ito. Tapos na tayo. We should now have the computation for our shipping cost. Ito na yung final na ating table. No? So, sige, shipping cost naman tayo. Same sa dati ang ating format ng computation for shipping cost. Let's have here first the root and our from to 2. From to 2. Okay. Units ship. Let's have your units ship. And yung cost per unit na siniship natin. Cost per unit. And lastly, we have here the total cost. Okay. Ayan. Let's have first this one. Okay na ito. 0 naman siya, no? So, unahin natin sa ating shipping cost computation is the Hanoi to Sydney, which is 300 na units. So let's have here Hanoi to Sydney. Number of units shipped is 300. Cost per unit natin is $2. Ayan, $2. So, basically, multiply natin sila para makuha ang ating total cost. 300 times 2 is 600. Okay, next. Okay na to. Ito, okay na rin dahil 0 naman siya. 404 from Manila to Seoul. So, let's have here Manila to Seoul. Again, 400 units and $4 per unit. Okay. So, 400 times 4, this is 1,600 total cost for that transaction or for that shipment. Okay, and 0 naman siya, cancel na to. Next, we have Manila to Tokyo. So, let's have here Manila to Tokyo. Manila to Tokyo, we have 100 units na need to ship and that is $6. Cancel ko na, no? $106. So, 6 times 100, that is $600. Okay, next. Ito, wala na. 0 naman. Same with this one. Beijing to Tokyo. No, Beijing to Tokyo. Let's have here, Beijing to Tokyo. Beijing to Tokyo. Okay, ang units na isi-ship daw natin from Beijing going to Tokyo is 100 and $3 per unit. Okay. So, 3 times 100, that is $300. Okay, so okay na ito. For the dummy to Seoul, we have 200. Baka may magtanong, sir, baka hindi na po sana ilagay yan kasi dami naman, no? Actually, pwede naman kasi mag-result sa'yo yan na 0 din naman. Pero for the proper computation, ilagay natin. No? Kasi part pa rin siya ng computation. Kahit na 0 yung binigay niyang value. So, we have 200 and 0. So, $0. Ayan. And, okay na to. So, dami to Sydney, meron din. We have here dami going to Sydney. At gaano karami yung units na isi-ship niya, that is 100. So, 100 units ship and yung cost is 0. Since dami naman, i-cancel ko na ito. Bakit naman tayo ito pala? 0. And 0 ang ating total cost. Last and final na step na kailangan natin gawin is to get the summation of our total cost, which are, ang data natin is $600, $1,600, $600, $300, 0 and 0. Okay? And ang total niya actually is 3,100. And this is now our optimal solution for VAM. No? So, kung titignan nyo, mas maliit talaga ang binibigay ni VAM compare sa Northwest and sa East Coast. Sige, ikumpara natin. I hope you have your notes with you right now. Lagay natin dito sa Northwest corner rule. Kung babalikan ninyo ang notes, we have a total cost of 5,900. And for the least cost method, we have a total cost of 3,400. Uy, ang laki. Dito pa lang no? Nakikita nyo na from 5,900, bumabagsak siya ng 3,400. Malaking tipid na yun. No? Ang laki na ng savings mo nun. Itong 3,400, kaya mo pa palang paliitin. No? Akala mo maliit na yun, pero may ililiit pa siya. No? And that is actually by using the VAM or the Vogel's approximation method, which is nagbigay sa atin, based sa ating sagot kanina, that is 3,100. 3,100. And this is actually our optimal solution. No? Ayan yung pinaka. Now, sir, lagi bang VAM ang pinakamaliit? Usually, ganun na nangyayari, pero hindi yan standard. May mga cases, may mga chances na si LCM ang pinakamaliit. Isa naman si NWCR. Pero more likely, yan sa lahat ng mga problems na na-encounter, pinaka maliit talaga si VAM. No? So, this is not the end of transportation model. Marami pang iba. No, may kadugtong pa nga ito actually yung tinatawag nating MODI or the modified distribution and yung isa na stepping stone method. So, for now, ito muna tayong tatlo ng mga basic transportation models. Again, we have the northwest corner rule, the least cost method, and the Vogel's approximation method. They can all be applied sa ating balanced and of course, sa ating unbalanced transportation model. Huwag niyong kakalimutan itong transportation model. Maraming application ito pagdating sa field. So, I hope you learned something from this presentation and I'm looking forward for the mastery of our subject. So, thank you for your participation. See you online again next discussion and keep safe always. Thank you. Bye-bye.